Hey guys, welcome to episode 52 of Reconstructing Cave Story. In this episode, we're going to be abstracting out our map collisions. This is going to be strictly refactoring. We're not going to add any new implementations or anything, but let me explain. The problem is right now the player is not the only thing that follows our map collision algorithm. And remember, our algorithm is update the velocity, then calculate the delta, then check collisions in the direction of delta, and if it collided, then set y or x, then do extra reactions like set the velocity. So the player isn't the only one who reacts in this way, and it's very, very similar for the other reactors. So experience pickups, for example, are another item in the game that collides with the map and then updates the velocity and then changes its velocity when it collides with the map, and then has to set its position when it collides with the map, and it's all following the same algorithm. And then there are many types of enemies, such as the first critter you see, which collides with the map and keeps on going. Right now our projectiles are kind of colliding with the map, but they don't really keep going or react in any super special way, so it's much simplified. It's much simpler than our algorithm for our player, but we have others that follow this algorithm we have for our player. Another one is our fireball projectiles, which bounce around. And then there's probably more. I just didn't think of, these three are more than enough to satisfy me to make it abstract. So let me just go over our algorithm again. It's generally the same when we abstract it as what it is for our player. And this is again in our player update X and update Y. So the first thing we do is update our velocity. Well, before that even we set our acceleration, then we update our velocity, then we calculate our delta. Then we check the collisions in the direction of delta, and if we collided, then we set y or x to be exactly at the boundary, exactly the boundary of the map tile. And then we do extra reactions, like usually we set velocity y to be equal to 0, or sometimes we set on ground to be true if we've collided. Otherwise, if there is no collision, then we apply delta. And then we do extra stuff if we actually apply delta, and the only example I can think of is on ground would become true if we do end up applying delta in the y direction, and that's because if we're either falling or going up and therefore are not on the ground. Then we check collisions in the other direction, and then again if we've collided we set y or x and then do extra reactions. So our solution is going to be basically three different objects to help abstract things. The first is kinematics, and it's just going to be a position and a velocity. And a lot of times what people do is they combine x and y and then velocity x and velocity y into one object. So two objects, so position and velocity would be two objects, both containing x and y. That's not how I'm doing it. This is just a single x, and this is velocity x, or y and velocity y. And why are we doing it with y kinematics? Well, with kinematics we can specialize our motion. For instance, gravity kinematics, like we could create a gravity kinematics which would derive from kinematics, and then this gravity kinematics, maybe we have an update velocity, and then it could automatically take care of the gravity for us without us having to worry about it or think about it. So it's just a way I think is going to be easier to abstract out different types of kinematics. And then we can also calculate delta easily. So not only is it going to have a position and a velocity, but it's also going to have a delta function, which is just velocity times elapsed time. So it's just going to take in this elapsed time. The second object we're going to do is a collision rectangle. So this is another abstraction we're going to need to make. This is just like we have implemented in our player bottom collision, left, right, top collision. But since we're abstracting out our map colliding stuff, we're going to need to have a collision rectangle that can create these left, right, top, and bottom collisions given in x, y, and delta. Because right now that's basically the inputs to our bottom collision. So let me show you what it is. This is kind of a big introduction because it's a big refactoring and it can get kind of hairy. So I like to go over it pretty detailed. So again, you can see our top collision, it's just got this delta, and then it's also a function of x and y, and it doesn't really look like it because x and y are part of the player struct, but when we take out this collision rectangle, we also need to pass in the x and y. And then finally, it's a bounding box, and that is just to help us figure out how far out to adjust our position. So this we use, like, we say, oh, we set it to row minus bounding box dot top, or row plus 1 minus bounding box dot bottom. Or I don't know if that's totally right. I don't think it is. So don't quote me on those figures. But yeah, that's what the bounding box is for, is just to kind of encompass all 4 of these collisions. And then this is another thing we're going to end up abstracting out later, because our player class has 4 rectangles. I know I call it 3, but I guess I'm going to start calling it 4 rectangles. But 4 rectangles which make up these special top, bottom, left, and right collisions. So you see we have this collision Y rectangle and this collision X rectangle that gets split in half. We're also going to have simpler collision rectangles where it's just one single collision rectangle that generates the whole thing. So this is going to be another abstract class. Yeah. So let's see. We won't abstract it in this episode, but we will in probably the next episode. Or yeah, probably the next episode. So then the last thing we have is this abstract MapCollidable object. And this is just anything that can collide with an object and follow this algorithm we have up here. So it's going to have this update X and update Y. We're separating them out so that the object itself can update its velocity and based on acceleration, but we might abstract that out later too. I don't know, but you'll see what this looks like. I don't think it'll be too foreign. Oh, and this is not going to take in XY, velocity X, velocity Y. This is going to take in kinematics X, and it's going to be a reference so that we can change the kinematics. And then it's also going to take in kinematics Y. And then elapsed time and our map so that it can just do all the necessary stuff for our algorithm. And then we'll have it on collision. And this is for when we have to do our extra reactions. So anytime we set Y or X after we've collided, we also have to do extra reactions like set on ground to be true or on ground to be false. So we'll have this extra on collision method, which the player can implement. And these are just going to be pure inside of our MapCollidable objects. You know, just equal 0. Just so that we can implement these inside of our player class differently from how we implement it inside of our experience drops. And then also we'll have an onDelta. So if delta has been added, if we apply our delta, then we also want to be notified of that. So it's just a kind of a handler function for those, or it's not really a callback because you don't pass it in, but it kind of looks like a callback. Anyway, so I have a pretty general implementation plan. We'll start out by creating the kinematics, and this is just so we can have at each stage something that we can test and something that we should know is working. Then we will, after we create the kinematics, we'll have the player use kinematics, and that should still be working. Then we will create the collision rectangle, still working again, and then player use the collision rectangle instead of the 2 rectangles it's using now, and this might actually make things simpler and easier to understand anyway. And then finally we will next we'll implement onCollision and onDelta for the player class, and then use those instead of actually explicitly setting on ground to true. So let me show you what I mean here. So player update X. So here, instead of setting velocity X to be equal to 0.0f, we will call onCollision. And then here, down here, instead of setting velocity, let's say onDelta, instead of setting on ground to equal to false, we'll call onDelta. And so that's what, that's kind of the mapping. So we'll move those out into their own functions. And then we'll finally move all the collision code into the MapCollidable object and then have the player implement MapCollidable. And then we'll be done with this episode. This might be an intense refactor, and it might go really smoothly. And it might all have to do with how well I type things. So yeah, let's get started. Sorry, it's a long introduction, but I just really want to go over it thoroughly so you have a good idea of what to expect. And I'll put a link in the video on where I actually get started. So let's get started now. So let's start with creating kinematics. So let's add new item. This will be the easiest one, I think. Header file. So I'm gonna actually just make we'll include units. I'm gonna make everything public, so it's easy to change. So units of game, position, units of velocity, velocity. And then we'll also do the delta, calculate delta. So this will be units of game, delta, taking in elapsed time, and just returning velocity times elapsed time. Is there anything else? No, that's it. So we have successfully completed step 1. Let's go to step 2, which is player uses kinematics X and kinematics Y instead of X and Y and velocity X and velocity Y. So this will be a bigger change, but I don't think it'll be too bad because we can just find and replace stuff. So let's go down to X and Y down here and just replace these two lines with kinematics, which we'll have to include kinematics X and kinematics Y. We'll go to the top and include it. So then we can go to player.h, or no, let's start in here. We'll search for X. So we'll want to find and replace all X's and then all Y's with kinematics X.position and kinematics Y.position. So I'm gonna start by replacing X with kinematics X.position. That worked. And then I'll replace Y with kinematics Y.position. So I did that in the .h file, so now I'm going to do that in the .cc file. Of course, it'll be a little bit more complicated because we also have the constructor to worry about. So kinematics Y, starting with that. Then find some kinematics X and replace that. So I got X, now I'll replace it with kinematics X.position. So next let's do velocity Y. So this is going to be replaced with kinematics, it'll be replaced with kinematics Y.velocity. And we can find velocity X and replace that with kinematics X.velocity. And then we'll go to the constructor and replace these kinematics X.position. We'll replace that with X, 0.0f, and this one with Y, 0.0f. Another thing we'll want is a constructor for our kinematics to make this easier. So I'll just make a quick one right here. Kinematics, taking in units game and velocity. And then filling those values in. And then that should work. I think that's all we need to do. So I'm going to build and see if this builds. And if it does, then I'm sure it's going to run just fine, but I will run it anyway. Seems to be building, so maybe I lucked out and this was an easy refactor. Okay, yeah, seems to be working, so let's move on to the next one.